When a new technology emerges which threatens the business of those providing an existing one, there are two approaches they can take. One is to try and hold back progress. The other is to see this new field as an opportunity to expand. As the railways were facing increasing competition on several fronts, they attempted to follow the latter approach. The companies believed at the time that in order to turn over a profit, half their traffic would need to consist of goods services. With so much of this being lost to road haulage, the companies began to buy lorries of their own, giving them a stake in their main rivals. The Big Four had an advantage over the road-bound haulage services, as they could organise journeys which combined the trains and the lorries together, providing a speedy long-distance delivery. But even they were increasingly often finding that it was cheaper and faster to deliver directly by road rather than go through the goods yards. And though the rail companies had the advantage of a hybrid transport network, they had a distinct disadvantage over the haulage companies due to a long-standing regulation which required them to take all cargo at a nationally regulated rate on a first-come, first-served basis. This had been necessary when the railways controlled virtually all goods transport, as it kept the market open to all businesses and prevented the companies from cherry-picking the most profitable cargoes. The road companies, though, had no such regulations. They could negotiate prices privately, and since the rail companies were required to publish all their rates, the road companies could easily set a price that was slightly lower. The Salter Report of 1933 helped level the market somewhat. First, it introduced licensing and safety regulations on road vehicles, as well as raising vehicle taxes, reining the lorries in somewhat. Secondly, it eased pricing regulations on the railways, but it failed to remove the first-come, first-served obligations, which were forcing the companies to subsidise unprofitable loads with profitable ones. As well as lorries, the companies were also buying aircraft, looking to expand into the emerging market of air travel. The Railway Air Service was formed in 1934, flying passengers between the big cities of the UK and even abroad. Trains at either end would shuttle passengers to the city centre. But once time spent shuttling was taken into account, air travel between major cities was not much faster than going directly by train. If the aircraft could fly directly between the larger stations, it would boost their business greatly. The problem was, the main stations tended to be in the middle of built-up areas, with no room for an airstrip. Architect Charles Glover believed he had a solution. He would build an airfield on the roof of King's Cross Station. An ambitious idea, which would have featured 8 runways branching out, with a taxiway round the outside. The scheme never got off the ground, as it would have required every building in the area to agree to make up the foundations. A simpler vehicle companies could use to cater to passengers was the motor bus. A law change in 1927 allowed rail companies to run motor bus routes for the first time. In sparsely populated areas, light railways had previously been used to shuttle passengers to the station. Buses served the same purpose more cheaply and more flexibly. They could pick people up from right outside their houses. The ability to run bus routes meant that rail companies can now replace unprofitable lines with cheaper bus services without affecting their income. This accelerated the rate at which lines were being closed. At the same time, the Big Four had inherited many parallel routes which had existed to allow rival companies to service the same area. Now that they owned both lines, there was no need to keep both of them open. All of this meant that from 1929, Britain's rail network began to shrink consistently year on year. Not everywhere was downsizing though. The London Underground was growing rapidly, both in terms of size and passenger numbers, largely due to the growth of Metroland. But the growth of the network created a problem for those trying to create a clear map for travellers. The maps of the time included all the twists and turns of the tunnels and could be quite hard to read. Getting the whole network to a single scale was a problem, since it left the central zone, where the vast majority of journeys were made, awkwardly squashed in the middle. It didn't help that early maps included extra details such as surface lines, streets, parks, tourist attractions, and even army barracks. In 1926, a man called Frederick Stingemore designed a simplified map, removing all surface features besides the River Thames, giving each line a bright and clear colour, and compressing, stretching and distorting many of the lines to make it easier to read. An electrical engineer called Harry Beck questioned why they should stop there. Taking inspiration from schematic drawings, he designed a map in which the geography of the stations was ignored completely, focusing only on the connections between them, with all lines drawn at 90 or 45 degree angles, all stations equispaced where possible, different symbols for interchange and standalone stations, and a uniform typeface on all the labels. In 1931, he submitted his design for the tube map, possibly the most iconic rail map in the world. Frank Pick of London Transport was apprehensive about the concept, but agreed to give it a trial run. The map instantly proved popular with the public, allowing travellers to work out at a glance where to go and where to change trains, with a single map covering the whole network. The map itself became a design icon, featured in artworks and tacky souvenirs the world over. Sadly, Beck never copyrighted his work, and barely received any payment for it in his lifetime. While the Underground was going strong, up on the surface, the nation's tramways were in serious jeopardy. For them, the growth in road traffic posed a more immediate problem. The lines had been designed to flow seamlessly with slower horse-drawn traffic. For faster-moving cars, these large, unmanoeuvrable bulks in the street were an increasing source of frustration. It didn't help that passengers would embark and disembark in the middle of the road, making the streets very chaotic indeed. With hindsight, it can be seen that when trams were removed from the streets, it had no serious effect on traffic flow, but to motoring organisations at the time, it seemed that getting rid of them could only be a good thing. In 1931, a parliamentary commission convened to agree on a uniform policy for the inner city's public transport networks. It featured many emphatic arguments both for and against the trams, but ultimately concluded that the trams were standing in the way of efforts to modernise the streets. However, there was one saving grace. Trams were bigger and could handle almost twice the passenger numbers of even the largest motor buses. For the busiest routes, the motor buses simply could not handle the load. Instead, the government advocated for a third option known as the trolleybus. Electric buses powered directly from overhead cables, thus experiencing none of the charging problems of later electric vehicles. A best of both worlds approach, combining the size and low running costs of trams with the manoeuvrability and low maintenance of motor buses. But even with the trolleybuses, the number of tram and tram-like networks in Britain saw a severe decline in the interwar years. The trolleybuses represented a successful attempt to reinvent the railway concept for the 20th century. Others were less successful. Experiments were done in various locations to create a bus which could run on both road and rail, using various methods of switching between the two. Though interesting in concept, they were outperformed by buses on the roads and by trains on the rails. Added to that was the limited applicability, and so the concept got nowhere. But the most ambitious attempt to reinvent the railway from this era came from a man called George Bennie. Inspired by the propeller-driven rail Zeppelin from Germany, he designed the Bennie Railplane, a propeller-driven monorail which could carry 48 passengers or light goods loads and be suspended over existing lines, providing light high-speed services on the track above, while the heavier, slower commuter and goods trains continued unabated on the track below. In 1930, he constructed a prototype 120-metre section of his track at Millingrave in Scotland. He claimed the railplane would be able to reach 200 km an hour. On the short track, it could barely manage a fraction of that, though testers said it accelerated and braked extraordinarily well. Bennie took this as a success and looked for investors to expand the scheme, but he struggled to find any. Building his suspension poles over long-distance railways would be very expensive, and it wasn't clear if there was enough demand to make the money back, nor was it clear how Bennie planned to handle bridges and tunnels. Meanwhile, the Big Four were looking to more conventional ways to win back the crowds. Increasingly, they turned to their greatest weapon, speed. The roads may have the edge in small local journeys, but in a world without motorways, they were badly outclassed at cross-country journeys. To sweeten the deal further, the companies began running car trains, where motorists could drive to the station, have their car loaded on the train, have a quick relaxing run to their destination, and then have a car to drive around in once they got there. In 1932, the government drastically relaxed speed regulations on the railways in light of a number of improvements to railway design, allowing trains to run at high speeds for longer and more safely than ever before. Now they could really open up the taps, and companies made every effort to show off their speed. They organised elaborate Top Gear-style races, pitting their trains against sports cars, speedboats and light aircraft, or simply conducting location-to-location races against other forms of transport. And when the trains weren't racing against things that weren't trains, they were racing against each other, as the Big Four all sought to outdo each other in high-speed services and publicity pieces. In 1932, a GWR Castle class, known as the Cheltenham Flyer, made a speed run between London and Swindon, covering the 124 kilometres in 56 minutes and 47 seconds, hitting a top speed of 149 kilometres an hour and averaging 131 across the run, the fastest average speed in the world at the time. LNER, meanwhile, reduced the running time of the Flying Scotsman service from 8 hours 15 to 7.5 hours, later 7 hours and 20 minutes. In 1934, equipped with a dynamometer on board to measure speed accurately, the Flying Scotsman became the first steam train confirmed to have surpassed 100 miles an hour, or 161 kilometres an hour. Previous claimants had relied on anecdotal evidence. The Flying Scotsman was chosen to make this run due to its fame rather than its ability. By this time, the A1 Pacific class had already been superseded by the A3 Pacific class. Within a few months of the Scotsman's record-breaking run, an A3 class on the same route, known as Papyrus, was able to hit 174 kilometres an hour. The A3's 2 was soon superseded by Sir Nigel Gresley's new design, the A4. It was a model designed with speed in mind. The most obvious change was the streamlining. Inspired by recent developments in race car design, in which cars were built to cut through the air smoothly, engineers around the world looked into how the principle could be applied to trains. But streamlining steam trains had an additional problem compared to other systems, as the shape had to not only cut through the air, but also avoid creating a slipstream that would blow smoke in the drivers' faces. This required extensive testing in wind tunnels. During one test, a technician carrying the plasticine model accidentally left a thumbprint on it just behind the smokestack, but it turned out that was the perfect shape to create an updraft that would drive smoke away, and so it was incorporated into the design. The streamlining reduced drag at top speed by 40%, but it also increased the weight. Gresley himself regarded it as a gimmick, since the most important changes happened under the surface, such as streamlined supply pipes, and a boiler that could handle an extra 2 bar of steam pressure. On their first run in 1935, the A4 class Silverlink was able to hit 180 kilometres an hour and covered the distance from London to Newcastle in 4 hours. In 1936, Another A4, known as Silver Fox, pushed the speed further, hitting 182 km an hour. Not only were the A4s fast, they were also reliable. In 1,510 runs of the Silver Jubilee service, only 10 ever suffered mechanical problems. Rivals LMS, meanwhile, have been lagging behind in terms of innovation. They had continued the Midland Railway's small engines policy, which favoured low running costs over high-speed performance. It was a sensible decision financially, but unfortunately, LMS's network had a lot of overlap with the other companies, and in the more competitive regions, they were losing business to their flashier rivals. In 1932, their policy was reversed, and a new chief designer brought in, known as William Stanier. He introduced many innovative new designs, most notable of which was the Princess Coronation class, designed to run on their West Coast main line, with many of the same improvements in streamlining and mechanical efficiency, along with larger cylinders and greater surface areas in the flues. This allowed the Coronation class to produce 1,872 kilowatts of power, or 2,511 horsepower, a figure not matched until well into the diesel era. On their inaugural run in 1937, their engine, known simply as Coronation, was able to break LNER's record with a speed of 183 km an hour. But the run almost ended in disaster. The brakes Coronation had been fitted with were insufficient to slow it down at high speeds, and they were heading for a curve outside of Crewe with a speed limit of 32 km an hour. Coronation hit it at around 87. Passengers and luggage were thrown to the floor, but by some miracle the train stayed on the tracks. In light of this, the two companies called an informal truce while they each fitted more powerful brakes to their expresses. Gresley also used the time to work on the Mallard. It would be an A4 with special modifications just for making a speed run. All the valves and fittings were tuned up to the maximum extent and a double blast pipe fitted to draw air to the furnace faster. In 1938, the Mallard set off, officially to test the brakes. Gresley waited until it was moving to announce to the press that he intended to take it up to full speed, too late for LNER or LMS to do anything about it. On a downhill section at Stoke Bank, between Grantham and Peterborough, the Mallard hit a top speed of 203 km an hour, or 126 miles an hour, a land speed record for steam trains which still stands to this very day. An observer watching the Mallard speed past would be forgiven for believing that the high age of the railways was alive and well. Sadly, it was not the case. Attention-grabbing publicity stunts were simply not translating into consistent business growth. Every year, the roads were getting stronger and the railways were getting weaker. But questions about the network's future would have to wait. In 1939, the Nazis invaded Poland, kicking off the European section of the Second World War. And Britain's railways would have a key role to play in the conflict once more. But that is a subject for next time. Thank you for watching. Don't forget to like, share and subscribe to help the channel grow. And why not check out my website for more examples of my artwork. I am currently working on part 13 of this series, which should be with you in the next couple of months. See you then.